Good morning, class. Sorry I'm not able to make it today, but I decided to do the notes for you, and then you can just copy along. Today we're going to be learning about the combined gas law. And just like the other gas laws that we have learned about in terms of temperature relationships, all temperatures need to be in Kelvin. So, as the name of the combined gas law suggests, it is a law that combines all of the laws that we have discussed so far, which is Boyle's, Charles, and Gay-Lussac's. So the formula for the combined gas law is pretty similar to the ones that we have dealt with before, but it's just a combination of them. It's going to be P1 V1 over T1 equals P2 V2 all over T2. So you can see we have Boyle's law. We have V1 over T1 equals V2 over T2, which is Charles's law. And then we have the P1 over T1 equaling P2 over T2, and that's going to be Gay-Lussac's law. Just like before, you don't have to memorize this. You just need to know how to apply it. You will be given the formula sheet just like you were on your quiz the other day. You'll be given this for the test as well. So really what we're going to be focused on is finding these finals either for P2, V2, or T2. So the final volume, which we'll call V2, is calculated by doing P1 V1 times T2 all over P2 T1 T2 is equal to P2 V2 times T1 all over P1 V1. And we have P2, which is going to be equal to P1 V1 times T2 all over V2 T1. Just be sure that you never have two pressures being multiplied by each other, or two volumes being multiplied, or even two temperatures being multiplied by each other. We want the units to cancel out. So if you want the pressures to cancel, you need one on top, one on bottom, and so forth with temperatures and volumes and so on. All right, let's do a couple examples. It says a 55 milliliter sample, so that is volume. I'm going to put that in my volume column. Has a pressure of 3.5 atmospheres at a temperature of 500 Kelvin, which is my temperature. Now, if the volumes change to 15 milliliters, which that is a decrease, and the temperature changed to 275 Kelvin, which is also a decrease, our job is to figure out what the final volume is, that P2. Well, if we think about it in terms of Boyle's law, if volume went down, pressure should go up. because they're inversely proportional. If we think of Gay-Lussac's law, if temperature went down, pressure should also go down, since they are directly related to each other. So now we have to figure out which one is it. It all depends on which one went up more, or I'm sorry, which one went down more, the temperature or the volume. Which one has more of an effect on that pressure? So we're going to use the formula P2 equals P1 V1 times T2 over V2 T1. P2 equals my P1, which is 3.50 atmospheres, times the 55 milliliters, times my temperature 2, which is 275 K. And that's going to be over my final volume, which is 15 milliliters, times my original temperature, 500 Kelvin. You'll notice that my milliliters will cancel out, that my temperature cancels out, and we should be able to calculate my P2. Now, I would like you to use the calculator and to plug in your problem just like this. You do 3.50 times 55.0 times 275 divided by, notice I didn't hit equal yet, 15 divided by 500. I did not hit equals. I'm going to hit enter now, and that'll give me a P2 of 7.058 atmospheres we need 3 sig figs because there's 3 here, 3, 3, 3, 3. So really P2 is equal to 7.06 atmospheres. And you'll notice that the effect was greater, it went up. So decreasing that volume had more of an effect than decreasing that temperature to make that pressure go up. All right, let's move on to the next example. It says 68.35 milliliters. Again, that's our volume. Of a gas has a pressure of 8.15 atmospheres at 368 Kelvin, which is our initial temperature. If the volume is changed to 122 milliliters, so now our volume went up, what is the temperature needed? So we need to find T2 for the pressure to be decreased to 5.80 atm. You'll see how as pressure is decreased, temperature should also decrease, and as volumes increased, the temperature should also then increase. We got to figure out which one it's going to be based on which one had a greater effect. Well, T2 can be calculated by multiplying P2, V2, and T1, and then dividing it by the product of P1, V1. Make sure when you're doing these problems, just like all the ones that we have done before, that you use your units. I know it seems like a lot of work, but it will help in the long run. So 5.80 atmospheres times 122 milliliters times our initial temperature, which is 368 Kelvin. All over our initial pressure, 8.15 atm, times our initial volume, 68.35 milliliters. I'll give you a second to plug that in. And you should come up to have 467 Kelvin. You only need 3 sig figs because there's 3 sig figs. There's 4 here, but you always go to the least amount when you're multiplying and dividing. So you'll notice now that the temperature actually went up in that case. Alright guys, good luck on the worksheet that you're going to get. Do the best that you can, and we will go over it as soon as I get back. Again, I am sorry for not being there. Hope you guys have a good day and help each other out, because I know we do have a lot of people in here that can help you. I suggest that you work with the people at your table, and have a good day. Thank you.